Hello friends, we are continuing our English course on modern cooking. The next topic is the elements in the simple curve, how we can determine their dimensions. Right? Previously we have seen about what are the elements. Now how to determine their dimensions. The elements of simple circular curve already we have seen. Length of the curve, it is denoted by small l. It can be determined by two ways. If the curve is designated by radius, so already we have based on radius and based on the degree of the curve. If it is by radius, the length of the arc T1, C, T2. What is T1? This is the point of commencement, and T2 is the point of tangency. In the curve, the midpoint is C. Okay. So the length of the curve T1, C, T2. It can be given by R into delta. What is R into the curve and the radius? Curve and the radius, and the subtended angle is delta. So the radius into the delta gives the length of the arc. If delta is in radian, right? If it is in delta is in 30 degree, 40 degree means, then we have to say R delta, we have to convert it into pi by 1. So it becomes the measurement for the length of the curve. So pi r delta by 180 or r delta by delta pi by 180 delta c. If the curve is designated by degree, the length of the arc 20 meter change, we have 20 meter, then the length of the arc is equal to 20 delta by d, where d is the degree of the curve. 3 degrees, so 4 degrees, so 5 degrees, so degrees of the value, and delta is you will get the length of the curve. This is the way. Yeah, predominantly compared to this, this is the one we predominantly use. So you try to remember this formula. The length of the curve is pi r delta by 180 degree. Okay. Next is the, we need to, now we have completed the T1, C, T2. This length of the curve we have determined. Now we need to determine the tangent length. This is the tangent, you already know about it. This is the back tangent, this is the forward tangent. Both the distance should be same. So if you determine this, we will also say. Okay. So here VT1 and VT2 are the tangent length. That has to be determined. So from triangle VT1, O, this is the biggest triangle, and since it is tangent, this is the 90 degrees. So it is a right angle triangle. So we need the tangent length is denoted by the capital T. So how we can say this delta by 2, tan delta by 2 gives tan delta by is equal to T by R. We require the T. So T is equal to R tan delta by 2. This formula also you need to remember. It is very simple, right? And you try to remember this figure also, right? Next is length of the curve. What is length of the curve? See, this is the curve, this is the tangent, this is the long chord. This long chord length has to be determined, and it can be denoted by the capital L. Small l is the length of the curve and capital L is the length of the chord. This has to be determined, right? So the figure T1, T2 is the long chord, which I have said. Length of the long chord capital L is equal to 2 into T1D. What is T1D? Half of the thing they have taken. If you determine this half, the second half you can have into 2. So now they have considered the triangle. This is the triangle and this is the 90 degree. Right? We required this distance. So tan delta by sin delta by 2 is equal to opposite by hypotenuse. Opposite is the L by 2. This fullest L means is L by 2 by R, that is L by 2R, right? We required L, so 2R sine delta by 2 into 2R sine delta by 2. That is the final answer. If you remember that sine delta by 2, they have denoted with the notations, and it was arrived to the 2R sine delta by 2. You remember the length of the long chord formula is 2R sine delta by 2. Length of the curve is pi r delta by 180 degree, and tangent length is r tan delta by 2. You try to remember these formulas. And the apex distance or the external distance E. This is the apex distance. This they have denoted by small capital E as the notation for the apex distance. This has to be determined. How we can determine? From the figure, VC is the external distance. VC is the external distance. External distance VC can be determined by from OV minus OC. What is OV? OV minus OC, and OC, you know, it is the radius of the curve, right? And we need to determine the OV, right? From triangle VT1O, what is VT1O? VT1O, again we required this hypotenuse. Since it is a 90 degree, you can get this one. How you can get? Cos delta by 2 is equal to R by OB, right? So that is the clue here. OB is equal to R cos delta by 2. So cos delta by is equal to R by OB. So we required OB R by cos delta by 2. In trigonometrical logic, 1 by cos is equal to C. So R sec delta by 2, right? And you substitute this OB here, R sec delta by 2 minus R. R can be taken out as common. So C delta by 2 minus 1. So this formula also you can use it to determine the apex distance, right? Next one is mid-ordinate. What is mid-ordinate? See, this is E, apex distance, and this is the mid-ordinate of the curve. This distance DC has to be determined, right? So again the logic we can use OC minus OD. If you are able to get, then you can get the DC. What is OC is R, OD has to be determined. Again you can have this triangle such that you can determine the OD, right? OD can be determined by, again you can use cos adjacent by hypotenuse. So OD by R. So R cos delta by 2 gives the OD. R minus R cos delta by 2. So R can be taken out. 1 minus cos delta by 2. That is the thing you will obtain. So mid-ordinate BC or CD required is OC minus OD, right? OC, you know, it is radius of the curve, and OD has to be determined from the triangle which I said T1BO. Cos delta by 2 is equal to OD by T1, and OD by OT1 is R. So R cos delta by 2 is OD. Substitute those values, you get the formula. The mid-ordinate is denoted by capital M, R into 1 minus cos delta by 2. These formulas you try to remember and understand, and if you are able to draw the diagram and you can get the logic, you can get the formula also, right? Next, in the field, how we can set this simple curve. First step, we need to locate the tangent point, right? Tangent points are T1 and T2 has to be located. For that, the intersection point is V or I. In that only we can have the chainage distance, and we can set the theodolite there, right? So by tape measurement, intersection of both tangent point V, point of intersection, has to be measured and it has to be fixed. Set the theodolite at V, that is the intersection point, and measure angle pi. What is pi? The intersection angle. Pi, the outer is deflection angle, right? So from that you can determine the deflection angle is equal to 180 minus pi, right? So if you get that deflection angle, you can know. So the pi can be set by the measure by theodolite, or we can use the theodolite to set that angle, right? So calculate the tangent length. Already you know about r, radius of the curve, without knowing that radius of the curve, and the deflection angle you have obtained here. So you have to calculate the tangent length. From V, what is the distance? Both the direction you can set it. So fix the point T1 and T2. That is the first step to set out the curve. Then chainage of tangent. What is chainage of tangent? The chainage at V, or chainage at T1, or chainage at T2. These three values must be known. What is chainage? From somewhere else in the road, they keep on measuring the distance. At that point T1 or T2, the changeover is going to happen. Till that, before that, the measurement is known as the chainage, right? From that chainage to V, and from V to T2. If you are able, if the given data is given, the tangent length either from chainage of V is known, deduct the tangent length, you will get the chainage at T1, and add the length of the curve, you will get the chainage at T2. It's the logic, right? So that is the thing here given. Chainage of point A is the starting point of the chain line. Chainage of point V, that is the intersection point. B, D are measured from the point A. B is the other end, right? So the chainage at T1 is equal to chainage at V minus tangent length. You will get the chainage at T1, and T2 chainage is plus length of the curve. Length of the curve, you know the formula, pi r delta by 180, right? And after these things, we need to set the normal chord and the subchord. What are the normal chord? Normal chord are equal in all the area. It may be 20 or 30 meters. Predominantly 20 is better. For alignment, pegs are driven at those points. The distance between two pegs is normally 20 meters. The peg station are called main station. The chord joining the tangent point T1 and the first peg station is the first subchord. It may not be 20 meters, it is less than 20 meters, right? All the chord joining adjacent peg stations are full chord or normal chord, since they are on equal distance, 20, 20, 20, right? The length of the normal chord is 20 meters. The point joining the last main peg station and the T2, that is the last subchord. So for setting out of curve, you have to remember that normal chords will be there, two subchords will be there. So these distance has to be determined first, then you have to set it, right? I hope you have to remember the formula for the length of the curve, length of the tangent, length of the long chord, mid-ordinate, apex distance, and how to set in the field, right? Hope you understood. Thank you.